This is Sleepy Science Explained, and it's good to have you here. Let's go down into the deep ocean, not to conquer it, but to sit with the questions it still keeps. It is the largest place on Earth and the least seen. Sunlight fades a few hundred yards down, and below that lies a dark world that covers most of our planet. We have driven rovers across Mars and mapped its craters in fine detail. Yet we have charted only a small slice of our own seafloor in that same close way. No ships vanish by magic down there, whatever the old tales of a cursed triangle of sea once claimed. The real wonder is quieter and much harder. A whole world sits beneath the waves, cold and crushing and alive, and most of it no human eye has ever seen. We'll walk the honest edge of what we know and let the rest stay open. If you'd like more of these quiet hours, a soft subscribe helps another curious mind find us. And I'm always a little curious. Where in the world are you listening from? Now settle in. Let your shoulders soften and your eyes grow heavy. We'll begin at the last of the light. Below a few hundred yards of water, the sunlight simply runs out. The sea is layered by light. The top layer, where the water still glows, is called the sunlit zone. It reaches down about as far as 2 soccer fields laid end to end. Below that, the blue turns cold and dim, and scientists call it the twilight zone. There the light is like the last minutes of dusk that never quite end, a little deeper, and even that faint grey is gone. From there down, the ocean is truly black, all the way to the floor. Most of the sea, by far, lies in this darkness. Picture the whole ocean as a tall building of many floors. The sunlit part would be only the roof. Every level below sits in shadow. Gather every place on the planet where animals can live, and most of that room would be here. It would be water with no light, no seasons, and no day. It is the biggest living space on Earth, and the one we know the least. The largest room in the world, and the least lit. The ocean is far deeper on average than most people ever picture. If the sea were drained tomorrow, the ground beneath it would not be a gentle dip. On average, the ocean floor sits about 2.5 miles down. That is deep enough to sink almost any mountain on land and still leave water on top. The tallest peak we know, Mount Everest, could be dropped into the deepest trench and vanish under more than a mile of sea. Yet most of the floor is not trench at all. Most of it is a wide, muddy plain, flatter and more even than any desert up here. These abyssal plains are some of the smoothest, most level places anywhere on Earth. A ball rolled across one would find almost nothing to stop it for miles. They stretch on and on in the cold and the quiet, larger than whole continents, and almost none of them have ever been seen up close. We know the average depth well, yet the ground itself remains a stranger, a plain wider than continents, resting unseen. The pressure in the deep ocean is heavier than almost anything we meet on land. Water is heavy, and it piles up with depth. Every 10 yards deeper adds about the weight of one more sky pressing down. At the bottom of the deepest trench, the pressure is more than 1,000 times what we feel at the surface. It is like balancing a large adult elephant on every square inch of a person, all at once. A foam cup sent down on a cable comes back shrunk to the size of a thimble, squeezed hard and even on every side. Steel research subs are built as thick, round balls just to hold that grip back. And still, small, soft animals live down there without a single bone. Their bodies are mostly water, and water pushes back as hard as it is pushed, so the sea cannot crush what has no pocket of air to give. Where a metal ship would fold, a soft body simply holds. Life meets the great weight not by fighting it, but by matching it. A weight beyond feeling, held softly by the soft. Past a certain depth, the darkness is complete and never lifts. Below about half a mile, no sunlight reaches at all. Scientists call this the midnight zone, and the name is honest. There is no dawn here, no season, no change in the sky, because there is no sky. The water stays a steady, deep cold, close to the chill of a home refrigerator, age after age. The only light that ever appears is light the animals make themselves. A glow flickers, drifts and fades, and then the black returns. Whole lifetimes pass in creatures that have never once met the sun. This zone is not a thin band either. It makes up a huge share of the ocean, layer upon layer of steady night. Stacked together, it dwarfs every cave and every shadow on land. It is, quite plainly, the largest patch of lasting darkness on the planet. And it has been this way far longer than there have been eyes to notice. Down here, the idea of morning has no meaning at all. There is only the cold, the quiet, and the slow patience of the deep. Night without end, and no one waiting for morning. There is a spot in the ocean farther from land than any other place on Earth. Sailors and scientists call it Point Nemo, out in the South Pacific. From there, the nearest dry land is more than 1,000 miles away in every direction. The closest humans are often not on any shore at all. They are the astronauts passing overhead on the space station a few hundred miles up. So a swimmer floating at Point Nemo might have their nearest neighbors in orbit, not on the sea. The water there is deep, cold, and strangely empty of life, far from the rivers that feed the coasts. Space agencies even use it as a graveyard for old satellites, guiding them down to splash into that lonely stretch. Bits of many spent spacecraft now rest on the seabed far below. It is the emptiest doorway on a crowded world, a place so remote that the sky is closer than the land. Ships almost never pass this way, and few ever have. The water simply rolls on, empty and wide, under an empty sky. The loneliest water, with company only above. The longest mountain range on Earth is one almost no one has seen. It does not rise in the Alps or the Andes. It runs along the bottom of the sea. This chain is called the Mid-Ocean Ridge, and it winds around the whole globe like the seam on a baseball. End to end, it stretches more than 40,000 miles, far longer than any range on dry land. If it were lifted into the air, it would circle the planet with room to spare. Along its center, the sea floor is slowly splitting apart. Hot rock rises into the crack, cools and hardens, and the plates on either side drift away about as fast as a fingernail grows. Over ages, that slow parting has widened whole oceans and shifted the continents around the planet. Nearly all of this vast range sits in cold darkness, unmapped in fine detail. We have walked on the moon, yet we have barely glimpsed the greatest mountains of our own world. They are growing still, quietly, beneath the waves, the mightiest range on Earth, hidden under the sea. The deepest known point in the ocean lies in a trench near the far western Pacific. It is called the Challenger Deep, at the bottom of the Mariana Trench. The floor there is nearly 7 miles down. Set Mount Everest in that trench, and its peak would still sit more than a mile beneath the surface. Only a handful of people have ever traveled all the way to the bottom, fewer than have stood on the moon. The trip down alone takes hours in the small steel sub, sinking through layer after layer of cooling dark. The pressure at the floor could crush an ordinary submarine like a soda can underfoot. When the vessel's lights finally reach the bottom, they fall on pale, fine mud and a few small, patient animals. It is a hush that has never known a storm or a sound from the world above. No current hurries here and nothing rushes. The deepest place we know, and one of the least visited anywhere. Down here, nothing hurries and nothing changes, age after age. The bottom of the world, pale and far and still. Warm water and clouds of minerals pour out of cracks on the deep sea floor. In some places along the ridges, seawater sinks into the crust and meets hot rock below. It heats up, soaks up minerals, and rushes back out through tall chimneys of stone. These are called hydrothermal vents, and the darkest ones are known as black smokers. The water leaving them can be hotter than a kitchen oven, yet it does not boil because the pressure holds it down. As it hits the near-freezing sea, the minerals freeze out into black billows, like smoke from an underwater fire. Over time, those minerals pile up into chimneys that can grow taller than a house. Around these vents grow gardens of life that need no sunlight at all. Whole crowds of animals gather in the warmth, far below anything the sun can reach. It was a shock to science that such rich life could bloom in the dark. Researchers still find new vents each time they send cameras down. Fire and warmth kept in the coldest place there is. Some deep creatures live entirely without sunlight, feeding on chemicals in the water. Up here, almost all life runs on the sun. Plants catch sunlight, animals eat the plants, and the whole chain climbs from there. But around the deep vents, the base of life is different. Certain bacteria there feed on the chemicals rising from the crust, a bit like tiny factories running on the smell of rotten eggs. This trick is called chemosynthesis, and it turns Earth's own inner heat into food. On that base grows a whole living world of worms, crabs, and clams. Before we found these vents, most scientists thought the sun was the one true engine of life. Learning that a world could stand on something else changed what a living planet even needed. It widened the map of where life might be found. And it hinted that life could also hide in the dark seas of far-off moons. A whole living world built without a single ray of sun. It runs instead on the warmth and the chemistry of the planet itself, deep beneath the waves. A living world standing on the planet's own heat. A soft, endless snow drifts down through the deep ocean all the time. It is not frozen water. Scientists call it marine snow. Up in the sunlit sea, tiny plants and animals live, feed, and die. Their remains plump together with dust and waste into small, pale flakes. These flakes sink slowly through mile after mile of dark water. From below, it looks like a gentle snowfall that never stops and never settles for long. This drifting snow is the main meal for much of the deep. Animals far from any light wait for it, catch it, and pass its energy along. A single flake might take weeks to fall all the way to the bottom, drifting slower than a leaf on a still day. When it lands, it feeds the quiet creatures of the deepest mud. Even the trenches miles down are fed by this slow fall from above. The whole dark world lives on this patient gift, sinking grain by grain. Nothing here is wasted. What lived above becomes food below, drifting down to begin again. A snow that feeds the deep, falling without end. Most animals in the deep ocean make their own light. In the black mid-water, the ability to glow is not rare. It is the rule. Scientists who study the deep have found that most animals living there can produce light in their own bodies. They call it bioluminescence, a cold light made by a gentle chemical spark with almost no heat at all. It is the same soft trick a firefly uses on a summer lawn. A tiny shrimp might spit a glowing cloud to blind a hunter and slip away. A small fish might wear rows of blue lamps along its belly to erase its own shadow. Some animals glow to find a mate, others to lure a meal within reach. In a place with no sun, this living light does the work that sunlight does up here. It calls, it hunts, and it hides, all in flickers of blue and green. The deep looks empty and black, yet it is quietly full of soft, moving stars. A blackness lit from within, one spark at a time. The deep ocean is bitterly cold, almost everywhere, all the time. Down below the reach of the sun, the water settles into a steady chill. In most of the deep, it hovers just a few degrees above freezing, close to the cold of ice water in a glass. It barely changes from place to place or from age to age. There are no warm afternoons here and no cool evenings, only the same even cold. This cold slows life down. Many deep animals move gently, grow slowly, and can live a very long time. Their hearts beat at an unhurried pace, and a single meal may last them for months. A fish that would race in warm shallows will drift here like a slow thought. Warmth appears only in rare spots, near the vents where the crust leaks heat. Everywhere else, the deep holds one long, quiet, refrigerated calm. It is a stillness measured not in hours, but in ages. A fish that would dart in warm shallows drifts here as slow as a passing cloud. In this steady chill, a single life can stretch across many human ones. A cold, so even it feels almost like rest. When a great whale dies, its body becomes an island of life on the sea floor. A whale is one of the largest animals ever to live. When one dies and sinks, its body brings a huge gift of food to the hungry deep. Scientists call this a whale fall. First, sharks and other scavengers arrive and feed for months. Then smaller creatures move in to work over the bones and the mud around them. In time, even the skeleton itself becomes a home, as special worms and bacteria break down the fat locked in the bone. A single whale fall can feed a crowd of animals for years, sometimes for decades. On a plain where meals are rare and small, one fallen giant is a banquet. Some creatures seem to drift from one whalefall to the next, living off these scattered gifts. Without them, whole species might have nowhere to feed at all. So a single death opens a door of life on the empty floor. What ends up here so quietly begins as much as it closes. One quiet ending that feeds 100 lives. Every evening, a huge crowd of sea animals rises toward the surface, then sinks again by day. It is the largest movement of animals on Earth, and it happens over and over. As the light fades, countless small fish, shrimp, and jellies swim upward from the twilight zone. They come to feed in the richer water near the top, while the darkness hides them. As the light returns, they sink back down into the safe, dim depths. Early sonar crews once saw this crowd as a strange, false bottom on their screens. The layer seemed to rise and fall each day, and it puzzled them for years. We now know it was life itself, moving in a great daily tide. Billions upon billions of small bodies climb and drop, up and down, in the biggest commute on the planet. Stretched end to end, the travelers would outnumber every person many times over. It has run this way, quietly, since long before there were people to notice. A slow breathing of the sea, in and out, each day. A tide of living things rising and falling. We map the hidden seafloor mostly by listening, not by looking. Light cannot travel far in deep water, so a camera sees only a small pool of mud. Sound, though, travels well and far through the sea. So ships map the deep by sending pings downward and timing the echoes. A pulse leaves the ship, bounces off the bottom, and returns. From the delay, a computer works out how deep the floor is at that spot. Sweep the ship back and forth, and slowly a picture of the hidden ground appears. This tool is called sonar, and it is a bit like tapping a wall to find the beams behind it. It has revealed vast mountains and trenches no eye had ever seen. Yet even now, much of the fine detail is still missing. Most of the deep is known only as a rough, blurry shape, like a photo out of focus. We have listened to the floor far more than we have looked at it. The map of our own planet is still, in many places, a sketch, a world drawn not by sight, but by patient sound. The giant squid is real, though for centuries it lived mostly in sailors' tales. Old stories told of a great sea beast that could pull a ship under, and people called it the Kraken. For a long time, no one could prove such a huge squid existed. Then dead ones washed ashore, and their size was hard to believe. A giant squid can grow longer than a school bus, with eyes as wide as dinner plates, the largest eyes of any animal. Those great eyes gather what little light the deep allows, watching for danger in the gloom. Yet a living one was not filmed in its home waters until quite recently, after many patient years of trying. It turned out to be a shy, drifting hunter, not a ship-eating monster. The old Kraken was simply fear filling in for fact. Where sailors imagined a raging beast, the truth was a gentle giant in the dark. And that quiet truth, it turns out, is wonder enough. A real animal, drifting alone in the deep, needs no legend to be worth the watching. The monster was only a shy giant after all. The deepest diving mammal on Earth is the sperm whale, and it hunts in the dark. A sperm whale can hold its breath and slip down more than a mile below the waves. Down there, in water with no light, it hunts large squid. To find its prey, it does not use its eyes at all. Instead, it sends out clicks of sound and listens for the echoes coming back, the same trick a bat uses in a dark room. Its clicks are among the loudest sounds any animal makes, sharp enough to carry across miles of sea. A single dive can last more than an hour before the whale returns for air. It holds one breath through a journey deeper than most planes fly high. Scientists still study how such a warm-blooded animal survives the crushing cold and pressure so often, day after day. What we know is that it lives partly in our world of light and partly in the deep one. It crosses that border with every hunt and comes back to breathe. One breath held long in a world without light. There are lakes and rivers at the bottom of the sea, resting under the water itself. It sounds impossible, but the deep holds pools of water even heavier than the ocean around them. In some places, salt leaks up from below and mixes into the seawater near the floor. This makes a layer so salty and dense that it will not blend with the sea above it. Instead, it settles into a still pool with its own shimmering shore. From a submarine's lights, it looks just like a lake, complete with tiny waves lapping at the edge. There are even underwater rivers of this heavy brine, flowing along the seabed and pooling in the low spots. The brine is so salty that many animals cannot survive a dip in it. Some deep pools wear a rim of mussels around them, like reeds around a country pond. A submarine can even float on the surface of one, as if landing on a second sea. A lake within the ocean, quiet and strange and wholly real. A shore beneath the sea, with waves of its own. Scientists sort the deep ocean into layers, each with its own kind of life. The sea is not one single space, but a stack of worlds. Near the top is the sunlit zone, warm and green and full of familiar life. Below it lies the twilight zone, dim and cool, where strange fish hide from the fading light. Deeper still is the midnight zone, black and cold, lit only by living sparks. Below that comes the abyss, a vast plain of near freezing dark. And at the very bottom, In the trenches lies the Hadal zone, named for the old word for the underworld. Each layer has its own pressure, its own cold, and its own creatures. An animal built for one may be crushed or lost in another. It is a bit like the floors of a very tall tower, each with different tenants. Together they form a quiet ladder from light down into lasting night. Most rungs of that ladder have never felt the touch of a human hand. Worlds stacked upon world, from light to lasting night. The seafloor is dotted with thousands of drowned mountains called seamounts. Scattered across the deep are old volcanoes that never broke the surface. Each one rises from the plain like a lonely hill in the dark. Scientists call them seamounts, and they are far more than bare rock. Their slopes catch the passing currents and stir up food, so life gathers thick around them. Slow-growing corals cling to their sides, some older than the oldest trees on land. Fish, crabs, and drifting animals crowd these oases in the empty deep. A single seamount can hold its own small living world, cut off from the next by miles of plain. They act like islands, though no wave ever breaks upon their peaks. We have counted many thousands from the faint bumps they raise in the sea surface above. Yet only a tiny share have ever been visited or closely studied. Most of these hidden mountains remain quiet strangers, rich with life we have never met. Each rises alone from the plain, its slopes crowded with creatures found on no other peak. Drowned peaks, each holding a garden of its own. The anglerfish carries its own glowing lure in front of its mouth. In the black mid-water, finding a meal is hard, so some hunters bring their own bait. The deep-sea anglerfish grows a thin rod from its head that dangles a small glowing tip. The light comes from tiny bacteria living inside the lure, a gentle partnership between fish and germ. In the dark, that little lamp draws curious animals close, thinking they have found a snack. When they drift near, the wide jaws snap shut in an instant. The fish itself is small, soft, and slow, with a large mouth and needle teeth. It does not chase, it waits, letting its own light do the work. It can even go a long time between meals, so a single catch matters greatly. In a place where food is rare, a glowing dot in the black is a hard thing to resist. Patience in this animal has become a body plan. It fishes the dark with a light of its own making. A small light in the black and a waiting mouth. The colossal squid may be the heaviest squid in the world, yet no one has watched a grown one alive. The giant squid is long, but the colossal squid is built more heavily. It lives in the deep, chilly waters around Antarctica, far from most ships. Only a few whole ones have ever been caught, mostly by accident on fishing lines. Its body can outweigh a small car, and its arms carry hooks as well as suckers, sharp and swiveling. Its eyes are the largest known in the animal world, about the size of a dinner plate. Such huge eyes may help it spot the faint glow of a hunting whale from far off in the dark. Sperm whales bear round scars that seem to match those hooks, hinting at long struggles far below. But no one has ever seen a healthy adult swimming in its home waters. Whether it drifts and waits or hunts on the move, we honestly cannot yet say. Almost everything we claim about its life comes from the few dead bodies the sea has handed us. A giant we know mostly from its scars. The vampire squid is a gentle drifter, despite its fearsome name. Its name sounds frightening, and its looks do not help. It is a small, dark animal with red eyes and a cloak of skin between its arms. But it drinks no blood and hunts nothing living. Instead, it drifts in a dim, low-oxygen layer where few others can survive. There, it catches the marine snow falling from above, gathering the soft flakes with two thin, sticky threads. When startled, it does not flee in a rush. It folds its cloak up over itself like an umbrella turned inside out and simply waits for the danger to pass. It can also release a glowing cloud to confuse a hunter, then slip quietly aside. It uses very little energy, which is how it lives where oxygen is scarce. It is a patient recycler of the deep, living on what others let fall. That fearsome-sounding name hides one of the calmest animals in the sea, a dark cloak and the gentlest of appetites. The barrel-eye fish sees the world through a clear glass-like dome on its head. This small fish of the twilight zone has one of the strangest heads in the sea. The top of its skull is a see-through dome filled with clear fluid. Inside, two green, tube-shaped eyes point straight up through the dome. Looking up, the fish watches for the faint shadows of prey against the last of the light above. For years, people only knew it from damaged fish hauled up in nets, and the clear dome was always broken. So no one even knew the dome was there at all. Only when a deep camera filmed a living one did the truth appear. Its eyes can even rotate to look forward when it moves to feed, so it never loses sight of a meal. It is a living window, drifting quietly and watching the dim ceiling of its world. The whole body seems built around a single patient, upward stare. A creature made to look up and wait, a clear head tilted toward the last of the light. The Dumbo octopus flaps two soft fins like tiny elephant ears to move through the deep. Far down on the cold seafloor lives one of the gentlest animals in the ocean. It is a small, pale octopus with two rounded fins on its head. Those fins look just like the ears of a cartoon elephant, which is how it earned its friendly name. It waves them slowly to hover and glide above the mud, in no hurry at all. Unlike shallow octopuses, it does not shoot ink or dart away, for there are few hunters here to flee. It simply drifts down to the bottom and swallows small worms and shrimp whole. It lives deeper than almost any other octopus, in cold and quiet most animals never know. Films of it show a calm, drowsy creature, floating like a small ghost with wings. It seems to move as if the whole world were half asleep. In a harsh place, it looks almost peaceful, almost content. A soft flyer, drifting through the endless cold. Soft ears flapping, adrift in the quiet deep. Many deep-sea animals grow far larger than their shallow cousins, and no one is fully sure why. In the cold deep, some creatures reach unusual sizes. There are sea spiders as wide as dinner plates and isopods, cousins of the garden pillbug, that grow as large as a small cat. Scientists call this pattern deep-sea gigantism, and it appears again and again in the dark. The strange part is that we still cannot fully explain it. It seems to gather many possible causes without settling on one. Some point to the cold, which slows growth and may let these animals live longer, so they simply have more time to get big. Others suggest the low oxygen matters more, since larger bodies handle it differently. And still others think the scarcity of food and the great pressure shape their forms in ways we have not pinned down. For now, several forces seem to work together, and we cannot yet weigh them cleanly. For now, the size stays a question the cold keeps. The Yeti crab grows its own food on the hair of its arms. Near some deep vents lives a pale, blind crab with arms covered in fine bristles. The bristles look like white fur, which is how it got its smelly name. That fur is not just for show. Tiny bacteria grow thick along it, feeding on the chemicals leaking from the vent. The crab then combs the bristles with special mouthparts and eats the bacteria it has raised. In a way, it is a tiny farmer tending a crop of germs on its own body. It has even been seen waving its arms slowly over the warm vent water, as if fanning its garden to help the bacteria bloom. Move too far from the vent and the crop would starve, too close and the heat would harm it. So the crab holds a careful line between warmth and danger. In a place with no plants and no sun, it makes a living from a farm it carries with it. Life in the deep finds food in the oddest of ways. A small farmer tending a garden on its arms. Giant tube worms near the vents have no mouth and no stomach at all. Around some hydrothermal vents stand tall white tubes topped with soft red plumes. These are giant tube worms, and some grow taller than a person. What is strange is how they eat, because they do not eat at all, at least not the way we do. They have no mouth, no gut, and no way to swallow. Instead, billions of bacteria live packed inside their bodies. The worms' red plumes soak up chemicals from the vent water and pass them to the bacteria within. The bacteria turn those chemicals into food and share it back with their host. The worm gives shelter and a steady supply. The bacteria give dinner. It is one of the closest partnerships in all of nature, two lives folded into one. The red plumes even carry a special blood that lets the worm handle the vent's harsh gases. A living tube, standing in the warm dark, fed entirely from within. A body with no mouth, and never a hunger. Cold gas leaks up through the seafloor in places called cold seeps, and life gathers there too. Not all the food-rich spots in the deep are hot. In some places, gas and fluid ooze slowly up through the mud without any heat at all. Scientists call these cold seeps. The main gas rising there is methane, the same gas that burns in a kitchen stove. Special bacteria feed on it and, like the vent life, build a base of food from a chemical instead of the sun. On that base grow clams, mussels, and tube worms, sometimes in wide meadows on the seabed. Some of these animals live remarkably long lives, growing by tiny amounts each year. A single tube worm at a seep may be older than many nations. A whole seep community can persist for centuries in the quiet. These gentle leaks turn a barren plain into a crowded oasis. The deep finds a way to bloom even from a slow, cold breath of gas from below, a cold breath from the ground, and life gathers near. The Greenland shark may be the longest-lived animal with a backbone, though its exact age is hard to pin down. In the cold, dark waters of the far north swims a slow, heavy shark. It moves so gently that a person could almost swim alongside it. That slowness matches a very slow life. By studying the tissue in their eyes, researchers found that these sharks live astonishingly long. The oldest may be several hundred years old, older than any other animal with a backbone we know. It grows only a fraction of an inch each year and does not have young until it is well past 100. It ages so gently that the years seem almost to stand still around it. We can read a rough age from the lens of the eye, but not the exact years. The best estimates carry a wide margin stretching across whole lifetimes. So while it is clearly ancient, no one can say to the decade just how old the oldest truly are. A life so slow that even its years blur. Deep-sea corals build slowly in the dark and can live for thousands of years. Not all corals need warm, sunny water. Far below the light, cold water corals grow on rocks and seamounts. They do not carry the tiny sunlight-catching helpers that shallow reefs rely on. Instead, they feed by catching bits of marine snow drifting past on the current. Because food is scarce and the water is cold, they grow very slowly, sometimes less than the width of a hair each year. That slow pace adds up over immense stretches of time. Some deep black corals are among the oldest living things on the planet, older than the pyramids. A single colony may have been quietly growing since before written history began. They form fragile forests in the dark that shelter fish and other life. But a heavy net dragged across them can undo in minutes what took thousands of years to build. What grows this slowly cannot easily be replaced. Forests of the deep, older than our stories. A strange, deep-sea sound once thought to be a monster turned out to be ice. Years ago, underwater microphones picked up a very loud, low sound from the far South Seas. It was so powerful that instruments thousands of miles apart both heard it. People gave it a nickname, the bloop, and rumor filled the gap where facts were missing. Some imagined a giant, unknown creature calling in the deep. But scientists kept listening and comparing the sound to others they knew. In time, the answer became clear, and it was not alive at all. The bloop was the sound of a huge iceberg cracking and grinding as it broke free near Antarctica. Ice, under great strain, can groan and boom in ways that carry across an ocean. Once researchers matched the pattern to other icequakes, the beast simply melted away. The mystery dissolved into something real and quieter. Not a creature in the black, but the slow voice of cracking ice. Not a monster calling, only the groan of ice. Huge single waves that sailors once dismissed as legend are now known to be real. For a long time, sailors told of walls of water that rose from a calm sea and vanished. Scientists doubted them, thinking such rogue waves were only fear grown tall in the telling. Then instruments on a North Sea oil platform caught one and measured it clearly. A single wave had reared up far above the waves around it, tall as a building of several floors. Since then, satellites and buoys have recorded many more across the world's oceans. We now know these rogue waves are rare, but real, and they can appear even in open water. They seem to form when smaller waves line up and briefly pile their energy into one crest. A ship can meet one with almost no warning at all. The old sailors, so long doubted, were right after all. Sometimes, a story brushed aside as myth turns out to be plain, hard truth. The tale was true, and the sea proved it. Vast patches of the sea sometimes glow softly in the dark, and the cause is still unsettled. Sailors have long reported a rare sight called a milky sea. The water turns a steady, pale glow that can stretch for hundreds of miles, wide enough to be seen from space. Unlike the sparkling flashes of most sea light, this glow is even and calm, like a field of snow under a full moon. Researchers believe it comes from countless tiny bacteria, all glowing at once in the surface water. Some think the glow is a signal that helps the bacteria be eaten so they can spread inside a fish's gut. Others suspect it marks a bloom feeding on something drifting below. Satellites have now caught a few of these events from orbit, yet no ship has ever sampled one at its peak. So why so many light up together at once, across so huge an area, remains an open question. A quiet glow on the water, still keeping its reasons. The deep ocean holds a huge store of the planet's carbon, locked away in the cold. Carbon moves through air, water, and living things in a great slow cycle. The deep sea plays a large part in that cycle, mostly out of sight. When tiny surface plants die and sink, they carry carbon down with them as marine snow. Much of it settles into the cold deep, where it may rest for hundreds or thousands of years. In this way, the ocean acts like a vast, slow storehouse, holding carbon far from the air above. The deep water itself carries dissolved carbon that will not surface again for ages. Think of it as a great cellar beneath the world, keeping what the surface breathes out. This quiet storage helps steady the whole planet's climate over long stretches of time. Scientists still work to measure just how much the deep holds and how fast it moves. What is clear is that the dark sea is one of Earth's great patient keepers, a vast dark cellar holding the world's slow breath. A slow, worldwide current carries deep water around the whole planet, like a great conveyor belt. The ocean is not still. Deep beneath the surface waves, water moves in a slow global loop. In the cold far north and far south, surface water grows chilly and salty, which makes it heavy. It sinks into the deep and begins a long, quiet journey along the seafloor. Over centuries, this deep water creeps across the world, then slowly rises again in far-off seas. Scientists call this loop the Great Ocean Conveyor. A single parcel of water may take 1,000 years to finish the trip, drifting slower than a person strolls. As it moves, it carries heat, salt, and food, shaping weather and climate on the land above. When this loop shifts, whole regions can warm or cool over time. It is one of the largest slow motions on Earth, and almost none of it can be seen. The whole ocean turns gently out of sight. A river without banks circling the world unseen. The largest waterfall on Earth pours entirely underwater, deep beneath the North Atlantic. A waterfall usually needs a cliff and open air. But the biggest one on the planet flows below the sea, where no eye can watch it. It sits in the cold water between Greenland and Iceland, in a place called the Denmark Strait. There, dense, chilly water from the north spills over an undersea ridge and sinks toward the deeper basin beyond. This hidden cataract drops far farther than any waterfall on land, more than 2 miles down. It also carries a staggering flow, many times greater than all the rivers on Earth combined. Yet it makes no roar and throws no mist, because it is water falling gently through water. There is nothing to see and nothing to hear, only cold sinking into cold. It is a great, silent tumbling in the deep. One of the mightiest waterfalls we know, and one no person has ever seen. A waterfall in the deep, falling without a sound. No one knows exactly how many mountains rise from the deep sea floor. Seamounts, those drowned volcanoes, are scattered across the ocean floor by the thousands, but the true count is still uncertain. We can spot the larger ones by the small bumps they raise in the sea surface above them, which satellites can measure. That method finds the big peaks, but misses the smaller hills entirely. For every peak we have charted, many more likely rise unseen in the dark. The floor of our own planet is still, in large part, an unfinished map. New surveys keep turning up mountains no one knew were there. Depending on how a scientist counts, the number of seamounts ranges from tens of thousands to more than 100,000. Each new mapping effort tends to find more than the last. Because so little of the floor has been surveyed in fine detail, the honest answer is a wide range, not a firm figure. We are still, in a real sense, counting the mountains of our own planet. We can measure the sea, but not yet count its peaks. The deep sea floor is scattered with dark lumps of metal that grow astonishingly slowly. Across parts of the abyssal plain lie fields of small dark stones, each about the size of a potato. Scientists call them manganese nodules. They are made of metal that has gathered, layer by layer, around a tiny bit of shell or rock. The growing is almost unbelievably slow. A nodule may add only a few millimeters over 1 million years, slower than almost any process on Earth. That means a single lump the size of a fist has been forming since long before there were people. Whole fields of them rest on the mud, spaced out like scattered dark coins. They hold metals that people prize, which is why some companies now eye them for mining. But they are also home to slow, fragile life that clings to them in the dark. What took ages to form could be swept up in a single pass of a machine. A quiet field of stones, each one older than we can easily imagine. Stones that grow slower than the mountains rise. The deep ocean may hold far more living things than we ever guessed. For a long time, the deep was thought to be nearly empty, a cold desert with only scattered life. Newer studies hint that this picture was far too bare. In the twilight zone, sonar and nets suggest there are vastly more small fish than earlier counts showed, perhaps many times more. If that holds true, the deep would be far busier with life than anyone once believed. These small fish also carry food down each day, tying the bright surface to the dark below. But counting a crowd that scatters in the shadows is a hard thing to do well. Some researchers now think the weight of fish in that dim layer could outweigh the catch of every fishing fleet on Earth. Others urge caution, since these animals are hard to count and easy to overcount with sound alone. Either way, the deep looks far more crowded than the old maps of life suggested. We may be sharing the planet with a great multitude we have barely met, still uncounted in the dark. A fullness in the deep we are only starting to sense. The songs of great whales can travel across entire ocean basins. Some whales make deep, low calls that carry far better than any human voice. Sound moves quickly and far in seawater, especially the low notes a whale can produce. Under the right conditions, a call from one whale may reach another hundreds of miles away. Scientists once tracked a single low whale sound across a huge stretch of open ocean. The whales seem to use these long calls to stay in touch across the emptiness. In a world too wide to see across, they speak in sound instead of sight. A lonely note sent into the dark may find a listener far beyond the horizon. It is a bit like calling softly across a valley and hearing an answer from the next ridge. It is one of the longest conversations in all of nature. Across the cold and quiet, the deep carries their voices like a whisper across a still room. A voice sent far, seeking another in the deep. There is a hidden layer in the ocean that carries sound for thousands of miles. Sound does not travel evenly through the sea. It bends toward the depths where it moves most slowly. At a certain middle depth, this bending traps sound waves in a kind of natural channel. A noise made inside this layer can travel enormous distances before fading, far past the horizon. Scientists call it the sound channel, and it acts like a long pipe for sound in the open sea. A small charge set off in this layer has been heard clear across an ocean. Whales may use this same channel to send their calls the farthest. Navies once used it to listen for distant ships and quiet echoes from far away. A single sound here can outrun any ship and reach a coast days before a vessel could. It is an invisible highway for sound, folded into the middle of the sea. In the silent deep, this channel lets a whisper reach across the world. An unseen path where a whisper crosses the world. The frilled shark looks so ancient that people call it a living fossil. Deep in the twilight, water swims a long, thin shark that seems to belong to another age. Its body is more like an eel than a common shark, and it moves with a slow, snaking motion. It has rows of small, three-pronged teeth, hundreds of them set in a wide, pale mouth. Its close relatives are known mostly from fossils in old rock, so the living one seems to have stepped out of the deep past. It hunts soft prey like squid, likely by lunging forward in a sudden strike, the way a snake strikes at a mouse. It is rarely seen alive, since it lives far below where most nets reach. When one is filmed, it looks strange and old, a shape from an earlier chapter of life. Yet it is fully modern, quietly making its living in the dark. The shallow world moved on, but the deep let this old form remain, an old shape still swimming in the quiet deep. A fish once believed extinct for ages was found alive in the deep sea. The coelacanth is a large, heavy fish with thick, lobed fins that move almost like stubby legs. Scientists knew it only from old fossils and were sure it had died out with the dinosaurs. Then, off the coast of Africa, a fishing boat hauled one up, alive and unmistakable. It stunned the scientists who studied it, for here was a creature thought gone for tens of millions of years. Since then, more have been found in deep rocky caves along a few coasts. They rest by day in the dark and drift out to hunt once the light is gone. Their fins move in a slow, paired rhythm, a clue to how some fish long ago may have first neared land. It had been hiding in the deep the whole time, unseen but never gone. Extinct, it turned out, was only a word for out of sight. Thought lost for ages, alive in the quiet deep. One deep-sea octopus guards her eggs for years, longer than any other animal we know. On a cold, rocky ledge off the coast, scientists once found a pale octopus curled around her eggs. They returned again and again to check on her over the following years. Each time, she was still there, still guarding, slowly fanning fresh water over the growing eggs. She never left, and she did not seem to eat during all that time. Her watch lasted more than 4 years, the longest brooding known for any creature. Through season after season, she stayed at her post, growing thin and worn. Her body was spent almost entirely on the task, but her eggs hatched into healthy young, ready for the cold, dark ahead. She gave nearly everything she had so they might begin. It is one of the most patient acts of care ever seen in the sea. A mother's long vigil, kept in the cold and the quiet. A patient watch, given fully to what comes next. Most of the animals in the deep sea have never been named or described. Every time researchers send a camera or a net into the deep, they tend to find something new. A jelly no one has seen, a worm of an unknown kind, a fish without a name. The deep is so vast and so little visited that most of its life is still a stranger to science. For every creature we have named, many more likely drift past unrecorded. The books of life, when it comes to the deep, are mostly blank pages still. It may be that only a small fraction of deep-sea species have been found so far. It may be far fewer than that, with millions still hidden. No one can say for sure, because so few places have been sampled at all. What is certain is that the deep still keeps most of its living variety unseen. We share the planet with a crowd of neighbors we have never met, a world of neighbors, most still without a name. The twilight zone may hold more fish than the rest of the ocean combined, though counting them is hard. The dim layer below the sunlit sea, the twilight zone, is full of small fish and other animals. They hide there by day and rise in darkness to feed. Because they scatter and dodge, they are very hard to count. They spread out, dart aside, and slip past nets, so any tally is a rough one. Even our best guesses come with wide margins. When scientists measure them with sound, the numbers come out startlingly large, perhaps far greater than once thought. But sound can be fooled, since it bounces off gas and bodies in ways that are tricky to read. So the true amount is still uncertain, and may be much less than the boldest estimates. Either way, this shadowy layer seems to carry a huge share of the ocean's fish still unmeasured, and it feeds much of the deep by carrying food downward each day. A great crowd in the shadows, still hard to number. The longest animals in the sea are not whales, but drifting chains of tiny creatures. In the open midwater float strange animals called siphonophores. Each one looks like a single long glowing string, but it is really a colony. Many tiny bodies join together, each doing a job, so the whole acts as one animal. Some parts are for swimming, some for stinging, and some for feeding. Stretched out, one of these colonies can be longer than a blue whale, longer than a soccer field. Yet it is so thin and delicate that a careless touch tears it apart. It drifts through the dark, trailing curtains of stinging threads to catch small prey. Many of them glow, adding faint light to the black water around them. It is less like a single creature and more like a floating town, each part with its own task. They are among the longest and most fragile animals alive. A single life made of many, longer than any whale that swims, the longest life in the sea, thin as a thread. Some scientists think a simple sea animal may sit at the very base of the animal family tree. Comb jellies are soft, clear animals that drift through the sea, beating rows of tiny paddles that shimmer with color. For a long time, scientists thought simple sponges were the oldest branch of all animals. Then, new studies of their genes suggested comb jellies might branch off even earlier. If that was so, it would rewrite the very first page of the animal story. These paddle-beating drifters would then be older kin to us all. It is a small animal holding a very large question. One reading of the evidence says comb jellies came first, before sponges. Another holds that sponges are still the earliest branch, and that the gene signals are being misread. The debate has swung back and forth for years without a clear winner. What hangs on it is nothing less than the shape of the whole animal tree near its very root. For now, the earliest branch stays unanswered. Near the root of all animals, the order still unsure. Some of the largest single cells on Earth live quietly on the deep sea floor. Most living cells are far too small to see, but on the deep floor lie strange creatures called xenophyophores that break that rule. Each one is a single giant cell, yet it can grow as wide as a human hand. It builds itself a fragile shell by gluing together grains of sand and bits of debris from the seabed. These living lumps sit on the mud, gathering food from the water and the falling snow. They are so delicate that a net usually destroys them, so we know them mostly from careful deep cameras. Where they are common, they shelter many smaller animals among their forms, like stones sheltering life in a stream. Whole patches of the floor can be dotted with them, each a small castle of glued sand. A single cell, large enough to fill a palm, resting in the cold. It shows how odd and grand even the simplest life can grow in the deep. One cell, wide as a hand, alone on the floor. The deep sea may be the largest home for life on the planet, though how much lives there is uncertain. When we picture living things, we tend to think of forests, fields, and shallow reefs. But those are only a thin skin on the world. The deep ocean, dark and cold, is by sheer volume the biggest living space there is. It reaches for miles below the surface, across nearly the whole globe. No forest or plain on land comes close to holding as much room for life. Bacteria buried in the sea floor may make up an enormous share of all living matter on Earth, but no one can weigh it cleanly. The samples are few, and the mud runs deep, so the totals are rough guesses at best. It may be a modest amount, it may rival all the life on land. What is clear is that the deep is no empty desert, and that its true fullness is still being reckoned. The greatest home of life still being counted. The deepest parts of the ocean lie in narrow trenches called the Hadal Zone. Below the wide abyssal plain, the seafloor sometimes plunges into long, narrow cracks. These trenches reach the greatest depths in the sea, and scientists call them the Hadal Zone. The name comes from an old word for the underworld, which fits the crushing dark. Here the pressure is at its most extreme, greater than 1,000 times that of the surface. For a long time, people assumed nothing much could survive there. But cameras have found life even at the very bottom, including small pale fish and swarms of shrimp-like animals. These trenches also act as traps, gathering food and material that slides down their steep walls. Some are so deep that the whole of the tallest mountain could sink inside with room above. Because they are so hard to reach, they remain among the least explored places on Earth. We have sent far more machines to other planets than to the bottoms of these trenches. The deepest deep still keeps most of its secrets, the lowest ground on Earth and the least known. Traces of human-made plastic have reached even the deepest trench in the sea. The trenches feel like the farthest, most untouched places on the planet. Yet even there, our fingerprints have arrived. Deep diving vessels have brought back small animals from the very bottom of the deepest trench. When scientists looked inside their bodies, they found tiny bits of plastic. In some samples, nearly every animal held such fragments in its gut. Plastic breaks into ever smaller pieces, but does not truly disappear. It drifts down through the water and settles into the deepest folds of the sea. So the trash of the surface world has quietly reached a place no sunlight has ever touched. Even 7 miles down, in the coldest hush, our leavings have gone before us. It is a sobering thought, carried in the smallest of animals. The deepest quiet is no longer entirely apart from us. Our smallest litter, resting in the deepest hush. The deepest living fish ever filmed is a small, pale, gentle snailfish. For years, scientists wondered how deep a fish could possibly live. Cameras lowered into the trenches finally gave an answer. Near the very bottom, several miles down, they filmed small fish drifting calmly through the beam of light. These are snailfish, soft-bodied and almost see-through, with no real scales at all. They look fragile, yet they thrive under pressure that would crush a submarine of steel. Their bodies are built to match the sea around them, with special substances inside that keep their cells working. They swim slowly over the mud, hunting tiny shrimp-like animals that share the depths. They seem untroubled by a weight that seems impossible to us. Where we imagined only barren mud, a quiet little fish makes its home. The deepest fish is not a fearsome beast, but a soft, patient swimmer. Life, it turns out, reaches almost to the very floor of the world. A soft, small fish, at home where steel would fail. There seems to be a depth beyond which no fish can live, and we're still learning why. Fish have been found deep in the trenches, but not all the way to the bottom of the deepest ones. Below a certain point, several miles down, fish seem to vanish, though other animals carry on. Scientists think the reason lies in the chemistry of their cells under crushing pressure. To keep their cells working under such force, fish rely on a special substance in their tissues. The leading idea is that, past a certain depth, they would need so much of it that their bodies simply could not cope. So there may be a natural flaw for fish life, set not by cold or dark, but by pressure itself. Whether that limit is fixed, or whether some unknown fish slips past it, no one can yet say. The exact edge of where fish can live is still being drawn, a flaw for fish, and the reason still coming clear. The deep trenches act as quiet traps, gathering carbon from the world above. The trenches are the lowest points on the seafloor, and things tend to slide toward the bottom. Marine snow, dead animals and mud all drift down and collect in these deep folds. Along the way, they carry carbon from the surface world into the deepest sea. Studies show that trenches gather far more of this material than the flat plains nearby. It is a bit like the way leaves and dust settle into the low corners of a yard. Once it lands there, in the cold and dark and pressure, it may stay for a very long time. In this way, the deepest cracks in the crust help lock carbon away from the air. They are small in area, but do more than their share of this quiet work. scientists are still measuring just how much they hold. What is clear is that even the loneliest trench is tied to the breath of the whole planet. The deepest cracks quietly holding the world's carbon. The giant shark called Megalodon is long gone, no matter the stories that keep it alive. Millions of years ago, a huge shark hunted the seas. We call it Megalodon, and its teeth, as large as a human hand, still turn up in old rock and on beaches. From those teeth, scientists judge it grew far larger than any shark alive today, perhaps as long as a school bus. Some tales suggest such a giant might still hide in the unexplored deep, but the evidence says otherwise, and clearly. Its teeth vanish from the rock record after a certain point, and none younger have ever been found. A predator that size would need vast amounts of food and would leave clear signs, yet there are none. It lived, it ruled the warm seas, and then it died out, long before people walked the earth. The deep is full of wonders, but this old giant is not among them. Sometimes the honest answer is simply that a thing is gone. A giant of the past, and only of the past. Only a few people have ever traveled to the very bottom of the deepest trench. The deepest point in the sea is nearly 7 miles down, and reaching it is a rare feat. The first crew to touch that bottom did so decades ago in a cramped steel craft, and stayed only briefly. For many years after, no one returned at all. It took a long gap before better vessels carried a few more explorers down. Even now, far more people have flown into space and have visited the deepest sea floor. The journey down takes hours of slow, dark sinking, and the pressure at the bottom is beyond harsh. A single crack in the vessel would mean the end in an instant. So the bottom of the world remains one of the least visited places anywhere. We gaze at distant planets, yet the floor of our own sea stays nearly untouched. The deepest deep is still, in truth, a frontier waiting quietly below. The bottom of the sea, reached by only a few. Some of the water in the deep sea has not touched the surface for 1,000 years. The deep ocean moves, but very slowly. Water that sinks in the cold far north or far south begins a long, quiet journey along the bottom. It creeps through the dark for century after century before it rises again. By measuring faint traces in the water, scientists can tell roughly how long ago it last saw the sky. In parts of the deep Pacific, that answer stretches to more than 1,000 years. So the water washing over a deep-sea worm today may have last felt sunlight before many nations were born. It has been drifting in the dark ever since, carrying its old chill and its old trapped air. This slow travel shapes climate and feeds life along the way. The deep holds not only ancient creatures, but ancient water. Time itself seems to pool and linger down in the cold. Water older than nations, still on its way home. There are wide zones in the ocean where very little oxygen can be found, and they may be changing. Animals need oxygen, and the sea usually carries plenty dissolved in its water. But in some middle depths, the oxygen runs low. Scientists call these oxygen minimum zones. They form where lots of sinking matter is broken down, using up the oxygen faster than it is replaced. In these zones, most familiar animals cannot survive for long. Yet life does not vanish. Special creatures like the vampire squid and certain worms are built to live where others would suffocate. There are signs that these low oxygen zones may be spreading in some seas, which scientists watch with care. But how far and how fast is still debated, since the ocean's records are patchy and the change is slow. For now, whether they grow steadily or shift and settle remains an open question. A layer thin on breath, its future still unsure. Where the common eel goes to breed in the deep sea is still not fully known. Eels live much of their lives in rivers and streams, but when it is time to breed, they slip down to the sea and swim far out into the open ocean. They are thought to spawn in a deep, weedy stretch of the Atlantic called the Sargasso Sea. There the water is warm and still, tangled with floating weed, far from any shore. It is a strange, quiet nursery at the heart of the ocean. The strange thing is that no one has ever clearly seen a wild adult eel spawn there. We find their tiny young drifting in that region, which points to it strongly. Yet the adults themselves seem to vanish into the deep, and their final act stays hidden. Scientists have tagged eels partway across the ocean, but the last leg keeps slipping from view. So one of the oldest questions in natural history remains unanswered. A journey we can trace, but not yet fully follow. A stretch of sea called the Bermuda Triangle holds no special curse. For decades, stories spread about a patch of the western Atlantic where ships and planes were said to vanish. People spoke of it as if some hidden force pulled them down. But careful study tells a plainer tale. This is a busy stretch of ocean with heavy traffic, sudden storms, and strong currents. Counted fairly, losses there are no greater than in other busy, stormy seas. Many famous cases turn out to have ordinary causes or were stretched in the retelling. The deep water there can swallow wreckage quickly, which makes disappearances feel stranger than they are. There is no magnet of doom, only weather, chance, and the vast, forgetful sea. The real ocean needs no curse to be humbling. Its plain risks are enough, and its plain truths are calmer than the myth. What looked like magic was only the ordinary sea, doing what the sea does. No curse in the water, only the ordinary sea. In the dark deep, many animals talk with flashes of light, though we cannot fully read them. Where there is no sunlight, living light becomes a language. Deep animals do not just glow by accident. Many use their light on purpose, in patterns and flashes. A flash may call for a mate, warn off a rival, or startle a hunter into letting go. Some fish carry rows of lights they can switch on and off, sending signals through the black. Because the water swallows other signals, light travels well and speaks clearly here. But we are only beginning to decode what these flashes mean. A pattern that reads as courtship to one scientist may be a warning or a lure to another. Much of this silent talk stays unexplained, since we cannot yet watch and listen the way the animals do. It is a whole world of messages, written in soft blue and green, still waiting to be read. The silent talk in flashes, not yet understood. Many deep-sea animals are colored red, which makes them nearly invisible in the dark. It seems odd that a bright red animal could be hard to see. But in the deep red is the perfect cloak. Sunlight is made of many colors, and red light is the first to be soaked up by water. Only a short way down, red light is already gone. So in the deep, there is no red light left to reflect off a red body. A red animal there simply looks black, blending into the endless dark. Many shrimp, fish, and jellies use this trick, wearing deep red to hide in plain sight. Some hunters answer with a red searchlight of their own to spot prey that thinks it is unseen. It is a quiet contest of hiding and finding, played out in colors we would never guess. What is loud up here is silent down there. Red, of all colors, becomes the very shade of the shadows. Bright red, and yet unseen in the endless deep. Some deep-sea creatures are so clear that light passes straight through them. Hiding in the open mid-water is hard, for there is nowhere to duck behind. So some animals take a different path. They make their bodies nearly transparent, as clear as glass. Light passes right through them, so a hunter sees almost nothing at all. Certain jellies, small squid, and tiny shrimp use this trick to vanish in plain sight. Even parts that might give them away, like the gut, may be hidden or curled small. A few carry only a single dark speck, an eye floating in an otherwise clear fawn. It is a strange sight in a deep camera's beam, a shape one can barely tell from the water. Being see-through is one of the oldest ways to disappear. In a place with nowhere to hide, some animals simply become the water around them. To see them at all is to catch a faint ripple where a creature ought to be. A body of glass lost in the water it swims. Cold, dark reefs of coral grow far below the sunny shallows we know. When people picture coral reefs, they imagine warm, bright, shallow water. But reefs grow in the cold deep too. In the dark, certain corals build large mounds and ridges on the seabed, far from any light. Without sunlight, they cannot rely on the tiny helpers that shallow corals keep. Instead, they feed by catching food from the passing current with their soft arms. Over long ages, they pile up into structures that shelter fish, crabs, and countless smaller creatures. These deep reefs form quiet cities of life on an otherwise bare floor. Some stretch for miles, hidden in the cold where no diver ever swims. Because they grow so slowly, they are easily harmed and slow to heal. A single heavy net can flatten what took centuries to rise. Scientists are still mapping where these hidden reefs stand. Even in the cold and dark, coral finds a way to build a home. Reefs in the cold, deep, quiet cities of life. The animals around a single deep vent can be wildly different from those at the next one. Hydrothermal vents are like scattered islands of warmth in a cold, dark sea. Life crowds around each one, feeding on the chemicals it leaks. But the vents are far apart, separated by miles of barren plain. So the creatures at one vent field may differ greatly from those at another. In one region, tall tube worms rule. In another, it is mounds of mussels or forests of shrimp. Each vent is a small, isolated world, shaped by chance and by whatever could reach it. When a vent finally goes quiet and cold, its whole community dies with it. It is a bit like scattered islands, each with its own strange animals found nowhere else. Yet somehow, new vents are found and settled by drifting young. Each warm spot is its own island, alive for a while, then gone dark and still. Islands of warmth, each with its own small world. At the edge of one deep brine pool, animals that wander in do not come back out. Deep on the seafloor sit those strange pools of extra salty water, too heavy to mix with the sea. Their edges look calm, even inviting, with a clear, shimmering surface. But the brine within is so salty that most animals cannot survive it. Fish or crabs that stray too far into the pool are quickly overcome. Their bodies may settle at the bottom, held for a long time in the harsh, still brine. Scientists who filmed one such pool gave it a grim, gentle nickname for this very reason. Around the rim, though, hardy mussels thrive, living off the chemicals seeping up. So the pool is both a trap and a garden, danger and life side by side. It is a lake within the sea, with a shore best left uncrossed. A calm pool, beautiful and unforgiving, resting in the dark. Its stillness is not peace, but a kind of quiet warning. A calm pool with a shore no wanderer crosses twice. Life claims a new, deep vent with unexpected speed, though how the young find it is a puzzle. Hydrothermal vents do not last forever. Old ones cool and die, and new ones break open elsewhere along the ridges. What amazes scientists is how quickly life claims a fresh vent. Bare new rock, warmed by the leaking heat, can be crowded with animals within just a few years. Tiny young of worms, crabs, and clams somehow arrive and settle the new warmth. Within a few short years, bare rock becomes a crowded, living town. But how they cross miles of cold, dark plain to find a vent they never knew is still unclear. Perhaps their young drift on deep currents and settle by luck. Perhaps they sense the faint chemistry in the water. No one yet knows for certain how the empty dark keeps delivering new settlers. The speed is plain to see. The how remains an open question. New warmth in the deep, and travelers we cannot trace. Some scientists think life on Earth may have begun in the deep sea near warm vents. Where did living things first arise? It is one of the oldest questions there is. One leading idea points to the deep sea floor near gentle warm vents. There, minerals, heat, and simple chemicals mix in ways that might spark the first steps toward life. The warmth is steady, the mix is rich, and the harsh sunlight of the young world never reaches down here. It is easy to see why some picture it as a sheltered, patient beginning. Whatever the truth, the deep keeps the cradle quietly, far past our reach in time. Some researchers favor these vents with their steady energy away from harsh sunlight. Others prefer warm ponds on early land, where cycles of wetting and drying could help instead. The trail is billions of years cold, so no one knows for certain. Still, the quiet, deep remains a strong candidate for the place it all began. Perhaps we began in the deep and rose toward the sun. We have explored only a tiny fraction of the deep sea floor with our own eyes. Ships have crossed every ocean, and sonar has sketched the rough shape of the floor. But truly seeing the deep up close is another matter. Only a very small share of the seabed has been observed in fine detail by cameras or human eyes. The rest is known, at best, as a blurry outline. This is why people say we have mapped other worlds better than our own. The far side of the Moon and the plains of Mars have been photographed in sharper detail than most of our seafloor. The deep is simply too vast, too dark, and too hard to reach. Each dive covers only a small patch of an enormous plain, so the honest truth stands. The largest part of our planet remains, for now, barely glimpsed. Most of our own world, still barely seen. A worldwide effort is now trying to map the entire ocean floor in detail. For most of history, our maps of the seabed have been rough and full of gaps. In recent years, scientists and sailors have joined a shared goal to map all of the ocean floor in fine detail. Research ships, survey vessels, and even ordinary boats gather sonar readings as they travel. Bit by bit, the blank spaces on the deep map are being filled. When the project began, only a small share of the floor was well mapped. That number has climbed steadily as data pours in from around the world. A good map of the deep helps with everything from safe travel to understanding climate. It also reveals mountains, trenches, and features never seen before. There is still a long way to go before the whole floor is charted. But for the first time, a full map of the deep feels within reach. Slowly, the last great map of Earth takes shape. People are now debating whether to mine the metal-rich stones of the deep sea floor. Those slow-growing metal nodules on the abyssal plain hold materials that industry wants. So companies have begun testing machines to gather them from the deep. This has stirred a serious debate. The nodules took millions of years to form and shelter fragile life around them. Scraping them up could harm creatures we have barely studied and stir clouds of mud across the seabed. Some argue the metals are needed for batteries and clean power up above. Others urge great caution, since the deep heals so slowly and we know so little about it. Scientists warn that damage here could last far longer than on land. The choice weighs today's wants against a world we do not yet understand. It is a rare case where a single decision reaches miles below the waves. The deep, so long left alone, now sits at a crossroads, an old, quiet floor now facing a hard choice. The deep sea carries traces of our world's noise, far from any shore. The deep can seem perfectly silent, but sound from above reaches down. Ships, drilling, and other human activity add a low hum to the water. Sound travels far in the sea, so this noise spreads over great distances. For animals that rely on sound, like whales, this added hum can make life harder. It can mask their calls and make it tougher to find one another across the open ocean. Scientists who lower microphones into the deep hear both natural sounds and our machines. Even in remote places, the background carries a faint mechanical drone. The good news is that this noise fades quickly if the source goes quiet, unlike plastic or chemicals. Still, it is another way the surface world touches the deep. The hush of the ocean is not quite as complete as it once was. Even the deep hush now carries our faint hum. Small robots and subs are our main way of visiting the deep sea. People cannot easily go to the deep, so we send machines in our place. Some are small subs that carry a few scientists inside a thick steel ball. Others are robots on long cables guided from a ship far above. These carry cameras, lights, and arms to gather samples from the dark. A pilot on the surface can steer a robot along the seabed, watching through its eyes. Newer machines can even roam on their own, mapping and filming without a cable at all. With these tools, we have filmed vents, trenches, and creatures never seen before. Each dive is slow, costly, and careful, covering only a small patch of the floor. Yet they are our windows into a world we cannot survive unaided. Through their steady lights, the deep slowly gives up its sights. Bit by bit, our robots let us look where our bodies cannot go. Machine eyes, opening the deep for us to see. Nearly every deep-sea expedition brings back a creature no one has ever recorded. The deep is so little explored that surprises are almost routine. When scientists dive or trawl in a new spot, they often find something unknown. It might be a new kind of sea cucumber, a strange jelly, or a fish without a name. Some voyages turn up dozens of unknown species in a single trip. This tells us just how much of the deep remains a blank in our books. Each find adds a small piece to a very large, unfinished picture. It also reminds us how young our knowledge of the sea really is. Whole families of life may still wait in the dark, unseen and unnamed. For a scientist, the deep is a place where wonder is nearly certain. To look almost anywhere new is to find something never known before. A deep so wide that finding the new is easy. One small research sub has carried scientists into the deep for generations. Among the tools of ocean science, a few small subs stand out. One in particular has dived into the deep thousands of times over many years. It holds a small crew inside a sphere, strong enough to resist the crushing pressure. Through tiny windows, scientists have watched vents, corals, and strange creatures up close. This sub helped confirm that life thrives around hydrothermal vents, changing what we thought was possible. It has explored wrecks, mapped ridges, and gathered samples from far below. Each dive is a slow, careful trip into a world that could crush a lesser craft. Over time, it has been rebuilt and improved to reach ever deeper. It stands as a quiet workhorse of discovery. Much of what we know of the living deep we owe to small, brave vessels like this one, a small sphere of steel carrying us into the deep. Floating robots now drift through the ocean, measuring the deep as they go. To understand the sea, scientists need readings from all over, not just where ships happen to sail. So they built a fleet of small floating robots and spread them across the oceans. Each one drifts with the currents, sinking deep and rising again on a slow, steady cycle. As it moves up and down, it measures the water's warmth, its saltiness, and more. Then it surfaces and sends its readings home by satellite before diving once more. Thousands of these floats now patrol the seas, day after day, year after year. Together they give the first steady, wide view of what the deep ocean is doing. Before them, our picture of the deep was patchy and rare. Now it grows fuller with every dive of every float. A quiet swarm of machines keeping watch on the hidden sea. A drifting swarm listening to the ocean's pulse. Scientists can now find deep-sea animals just from bits of DNA left in the water. Every animal sheds traces of itself as it moves, tiny flecks of skin, waste, and cells. These traces carry DNA, the code that tells one creature from another. Scientists have learned to scoop up seawater and read the DNA floating in it. From a single bottle of deep water, they can tell which animals have passed nearby. This lets them detect shy or rare creatures without ever seeing or catching them. It is a bit like reading footprints left in the water instead of the mud. In the hard-to-reach deep, this trick is a gift, since so much hides from cameras and nets. It has already hinted at animals in places we thought were empty. The method is still young and being refined. But it opens a new window on a world too vast to watch directly. Footprints in the water read to find the unseen. The ocean, most of it deep, has soaked up much of the extra heat building around the planet. When the world warms, the ocean does much of the quiet absorbing. Water can hold a great deal of heat, far more than air. So the sea has taken in a large share of the extra warmth building up around the Earth. Most of that heat has gone into the upper ocean, but some reaches into the deep. This slow storage has softened the changes we feel on land, at least for now. But it also means the sea itself is warming and shifting in ways that matter. Warmer water holds less oxygen and takes up more room, which slowly raises the level of the sea. The deep responds slowly, and what it takes in, it holds for a long time. Scientists watch these changes closely with floats and ships. The ocean is a vast, patient buffer, doing hidden work for the whole planet. A silent buffer holding the world's rising warmth. Beneath the seafloor lies a huge store of frozen gas, held in a cage of ice. In the cold, high-pressure mud of the deep, something unusual can form. Methane gas gets trapped inside a lattice of frozen water, making an icy solid. Scientists call it methane hydrate, and a piece of it can actually catch fire in a bare hand. There is a vast amount of it buried under the seafloor around the world. Where it seeps out, it can feed whole communities of vent-like life. Some worry that a warming ocean might, over long spans, let some of this gas escape and add to the warming. Others argue that most of it lies deep and cold enough to stay locked in place for ages. How much might ever be released, and how fast, is still debated and far from settled. For now, most of it rests quietly, a question buried in the mud. Fire held in ice, and a debate held with it. Most of the volcanoes on Earth erupt quietly, underwater, out of sight. When we think of volcanoes, we picture mountains of fire and ash on land, but those are only a small part of the story. The great majority of Earth's volcanic activity happens beneath the sea. Along the mid-ocean ridges, molten rock rises and cools almost constantly, building new sea floor. Most of these eruptions are gentle and slow, hidden under miles of water. Because they are so rarely caught in the act, no one is quite sure how often they occur. We know new rock is forming, yet the true count of deep eruptions is mostly an estimate. Now and then, instruments catch one by chance, a rare glimpse of the deep at work. How busy the seafloor really is from year to year stays an open question. The world's quietest fires, remaking the floor unseen. A strange field of pale stone towers rises from the deep, unlike any vents nearby. Far out on the seafloor stands a cluster of tall, ghostly white spires. Scientists named this field the Lost City, and it is unlike the dark, hot black smokers. Its towers are pale and made of soft rock, and the fluid leaking from them is warm rather than scalding. The chemistry here comes not from molten rock, but from seawater reacting with the crust itself. This gentle setting makes the right kind of chemicals to interest scientists who study the origin of life. Some think places like this could show how life's first steps might have begun. The towers grow slowly, some standing many stories tall. Odd little communities of microbes live on and within them. It is one of the strangest and most beautiful places found in the deep. A quiet white city, glowing faintly in the dark. Pale towers in the deep, hinting at our start. Discoveries in our own deep sea are reshaping the search for life beyond Earth. For a long time, scientists looked for life only where there was sunlight and warmth. Then they found thriving worlds around the dark, deep vents, feeding on chemicals alone. That changed the whole idea of where life might be possible. One view holds that if our deep can bloom without sunlight, then the hidden oceans beneath the icy moons of Jupiter and Saturn might do the same. Another cautions that we have no proof yet, and that any alien ocean may differ in ways we cannot guess. Whether life waits in those far waters, no one can yet say. Still, the deep sea has become a rehearsal for the search among the stars. What we learn in our own dark water guides where we look next in the sky. Our deep may hold the key to oceans far away. Some medicines and useful tools have come from creatures of the deep and the sea. The ocean's strange life is not only wondrous, it has helped us heal. Certain sea creatures make chemicals found nowhere else, shaped by lives in strange conditions. Scientists have drawn from these to make useful medicines and tools. A powerful painkiller was developed from the venom of a sea snail that hunts in the reef and deeper water. The blood of the horseshoe crab, an ancient sea animal, is used to keep medical supplies safe and clean. Other deep organisms hold promise for fighting illness that we are still exploring. Each one is a small gift from a world we barely know. It is a quiet reason to study and protect the sea's living variety. We cannot guess what help the next unknown creature might hold. In caring for the deep, we may also be caring for ourselves. Quiet gifts of healing, drawn from the deep sea. A giant, delicate animal builds a mucus house bigger than itself, then throws it away. Drifting in the midwater is a small animal called a larvacean, no bigger than a finger. What is strange is the home it builds around itself. From mucus, it spins a large, balloon-like house, sometimes as wide as a beach ball. This house works as a net, filtering tiny food from the water for the animal inside. When the fine filters clog, the animal simply abandons the whole thing. It sheds the old house and quickly builds a fresh one over and over. The cast-off houses sink, heavy with trapped food, feeding the deep below. So this tiny creature helps carry food and carbon down into the dark. A small animal, building and dropping mansions of slime, doing quiet work for the whole sea. In the deep, even one life's leavings become another's meal. A house of mucus, cast off to feed the deep. In some deep anglerfish, the tiny male fuses to the female and never lets go. Finding a mate in the vast dark is one of the hardest tasks in the deep. Some anglerfish solve it in an unusual way. The male is far smaller than the female, sometimes only a fraction of her size. When he finds her, he bites onto her body and holds fast. In time, his skin and blood vessels join with hers, and the two become one. He loses his eyes and much of his body, living on as a small attached partner. In return, he provides what she needs to make young whenever the time comes. A female may carry more than one such tiny mate fused to her side. It is one of the strangest partnerships in nature, born of a world too wide and dark to search twice. In the deep, even the search for a mate takes an unusual, lasting shape. Two lives made one, so neither searches alone. When a whale falls to the deep, life moves in through a clear order of visitors. A whalefall is not a single feast, but a series of them. First come the big scavengers, sharks and hagfish, tearing at the soft flesh for months. When the easy meat is gone, smaller animals arrive to work the scraps and the mud nearby. Worms, snails and crabs pick over what is left, cleaning the bones bit by bit. Then, in a final stage, special worms and bacteria break down the fat locked inside the skeleton itself. This last course can last for years, even decades, on a single whale. Each stage supports its own crowd of creatures, one following another. It is like a slow parade of guests, each taking their turn at the table. On a plane where food is scarce, this order lets one body feed many for a very long time. A single ending shared out across countless lives and years. One fallen giant feeding a slow parade of life. Certain deep octopuses gather at warm spots on the seabed, and how they find them is unclear. Octopuses are usually thought of as loners, each keeping to itself. But in a few deep places, scientists have found them gathered in crowds. At one warm rocky spot off the coast, dozens of octopuses were seen brooding their eggs together. The warmth leaking from the rock may help the eggs develop faster in the cold deep. So the mothers seem to come to these gentle hotspots to raise their young. How they find these rare warm patches across so much dark seabed, no one yet knows. Perhaps they sense the faint heat or follow cues we have not guessed. It is a rare sight, a nursery of octopuses in the deep, and much about it stays unexplained. The gathering is plain to see. The reason they manage it remains open. A quiet nursery gathered by means we can't yet name. Some deep-sea creatures glow with red light, a color almost no other animal can see. Most deep animals that make light glow blue or green, and most eyes there see only those colors. But a few hunters break the rule. Certain deep dragonfish carry a special light that shines deep red. To almost every other creature, that red light is invisible in the dark. So the dragonfish gains a private searchlight, one its prey cannot detect. It can spot a red-hued shrimp that believes itself perfectly hidden. Its own eyes are specially tuned to catch this red glow that others miss. It is like wearing night goggles no one else owns. In the endless dark, this trick gives the hunter a rare edge, a secret color, seen by only a few, shining where all else is blind. The deep rewards even the smallest advantage with a meal. A secret light, seen by the hunter alone. Most of our planet lies underwater, in the cold and the quiet. Water covers most of the Earth's face, and most of that water is deep, far below the reach of light. So the greatest part of our world is a dark, cold sea. It is still there, and slow, and mostly empty of us. We live on a thin, bright rim, and call the whole planet home. But the true bulk of it lies below, unlit and calm. Think of the land as a small lit porch on a vast, sleeping house. A wide, patient dark, holding more of the world than all our shores. Most of home is water, deep and still. The deep sea is the largest living space there is. Life is not only in forests and fields. It fills the deep, layer upon layer, mile after mile. By sheer volume, no home holds more life than the dark ocean. Most of it we have never seen. Small creatures drift and glow and settle in the cold. They live slow lives far from any sun. A single glow blinks and fades, and another answers. A whole living world, wider than all the rest, resting quietly below. It has no shore and no sky. It simply goes on, cold and calm, in every direction we could look. The greatest home of all, and the least known. Some deep water has not seen the sky for 1,000 years. Water sinks in the cold, far seas and begins a long, slow drift. It creeps through the deep for age after age. By the time it rises again, whole centuries have passed. The water washing a deep-sea worm today may be older than nations. It has carried its chill and its silence all that while. Time seems to pool and slow in the cold below. It moves slower than the hour hand of a clock. An old, patient water still on its long way home. Nothing hurries it along. It rises again only when its slow turn is done. Water older than memory, drifting still. In a world with no sun, the creatures make their own light. The deep is black, yet it is not without light. Most animals there can glow, each in its own soft way. A flicker calls a mate. A flash hides the fearful. A lure draws prey close through the black. These are cold, gentle lights made without heat. They drift and blink and fade across the dark water. Small living lamps, lit and let go. A darkness quietly full of soft, moving stars. No sun has ever reached them, yet the deep is never wholly black. Something is always glowing, somewhere below. A deep full of stars, each one alive. A soft snow falls through the deep all the time and feeds the dark. It is not made of ice, it is the remains of life from above. Tiny flakes drift down, slow and pale, through mile after mile. They fall for weeks before they ever reach the floor. Below, the quiet creatures wait and catch this gift. The whole dark world is fed by this slow fall. It settles like dust in an empty room. A gentle snow that never melts, feeding the deep. No wind stirs it. It falls straight and slow, hour after hour, onto the quiet floor. A snow that feeds the deep, falling always. A whale's low song can cross a whole ocean. In the deep, a whale sends out a long, low call. Sound travels far and well through the sea. The note carries on, past the horizon, into the dark. Somewhere, far off, another whale may hear it. Across a world too wide to see, they speak in sound. A single voice reaching out through the cold, like a word called softly across a valley. A call sent into the vast, hoping to be heard. The sea holds the note and carries it on. Miles away, it is still a whisper, and somewhere, perhaps, another whale is listening. A voice crossing the deep, seeking another. No one knows all that still waits in the deep. Every new dive tends to find something never seen. A new creature, a new vent, a new shape in the dark. The deep is so vast, and we have looked at so little. Most of its life has no name at all. What else drifts there unseen we cannot yet say. The question stays open, and gently so. It asks nothing of us but a little wonder. We have named so few of its lives. The rest drift on without us, unseen and unhurried, in the cold. A wide, dark, still keeping most of its secrets. So much still waiting quietly below. The same water circles the world, slowly, forever. The deep is not still. It turns in one great, slow loop. Water sinks in the cold, drifts along the floor, and rises far away. A single round may take 1,000 years. It carries heat and salt and food as it goes. Round and round, out of sight, the ocean breathes. Slower than any river we have ever watched. A current without banks, circling the whole quiet world. It sinks in the far cold seas and rises in warmer ones. Nothing rushes it. It has turned this way for ages and will turn so long after. A slow breath, in and out, that never quite ends. The same water, endlessly circling below. The deep keeps most of its secrets still. We have mapped the Moon and Mars more clearly than our own seafloor. We have named only a fraction of the life below. The largest place on Earth is still the least known. Its questions are patient and in no hurry. They have waited ages and can wait a little more. There is nothing to solve before rest. They will keep, as they always have. It has waited longer than we can hold in mind. It can wait a little longer still. There is time enough and quiet enough for all of it. A quiet deep, holding its wonders gently. So much still open, and no hurry to close it. The deep ocean is the nearest thing to another world, right here below us. It is dark and cold and strange, and it covers most of home. It holds creatures we have barely met and places we have never seen. Yet it is ours, close beneath the waves. A whole other world without ever leaving the earth. We have only begun to know it. It asks nothing of us. It only waits, cold and vast and near. A world within our own world, still mostly unknown. We have touched only its edges, and the rest lies open. And most of it still waits quietly in the deep. Another world waiting just below the waves. Along the way we followed the light as it faded into the twilight, and then the long midnight of the sea. We drifted past glowing fish and gentle giants, past worms fed from within and pale towers rising in the dark. We sat by warm vents and cold seeps, watched a snow that never melts fall for weeks, and heard a whale's voice cross an ocean. We passed drowned mountains and hidden waterfalls, and water older than nations, still on its slow way home. So much of it is still unseen, still unnamed, still waiting. No one has closed those questions yet, and you don't have to either. The deep has kept its secrets for ages. It can keep them a little longer, and so can you. Let the dark water grow calm now. Let the last small lights blink out one by one, and the deep settle into quiet. Let your shoulders soften, let your jaw unclench, and let your hands become still. Let your breath slow all on its own, the way the deep currents move, without any help from you. Whenever you wake, a like or a quiet word below tells us you'd like more of these calm hours, and that's how we learn to make the next one gentler. Another gentle journey is waiting on the screen whenever you're ready, though there's no hurry to reach for it now. Rest easy. Let the questions of the deep stay open, and let yourself drift down into the quiet. Good night.